Good day. Today we will be talking about the active and passive hot water supply system in the building services industry. My name is Christopher Heredia and I'm from the University of Belize. And first of all, we have to know why is it that we use this hot water in our homes or in a building. Hot water is an essential building services used for washing, cleaning, drinking, cooking, heating, and so on. It requires energy to heat water, and the types of hot water system installed in a building has a direct impact on its energy consumption. The main design considerations are the fuel type that will be used, whether the hot water will be generated locally or centrally, and whether it will be stored or generated on demand. While I did mention the locally or centrally system, I won't be going into that today. The two types of systems is the hot water active system and the passive hot water system. All solar water heating systems employ a collective area and a storage tank. Usually collectors consist of an insulated box containing a windy array of water pipes attached to metal sheeting or fins that have been painted black to absorb solar energy. Most collectors have a cover of either tempered glass or plastic to better contain the solar energy. The comparison between the two hot water supply system. The active system is mainly used for domestic hot water heating in colder regions, and it can also be used in warmer regions. Where the sun's heat energy is collected inside the solar collector, they transferred through the heat exchanger to the heat the water stored inside the storage tank. All active solar water heaters are designed to use a pump to circulate the solar thermal fluid through the system, also utilizing sensors and controllers, all working together to provide a high efficiency and better performance than the passive systems. The passive systems can be categorized as either direct or indirect. A direct passive solar water heating system is the simplest. The crudest form of direct passive solar water heating is a painting a water storage tank block to absorb heat in the water. Such systems were deployed in the past at summer campgrounds where facilities were mostly used during warm, sunny periods of the year. These systems must be drained dry at the end of the season to avoid damage from freezing, that is, if you live at a colder region. Passive systems do not use a pump to circulate water from the collector to storage or other location. They employ three means: gravity and a tendency of hot water to rise above cold water and water pressure. The active hot water system have five main parts: collector or collectors that capture solar radiation, pump to activate working fluid circulation, storage system for hot water, auxiliary or backup water heating system for use when sufficient hot water cannot be supplied by the solar system, and a set of control to regulate operation of the total system. Here a picture on the left side which demonstrate the process at which the active hot water system go about. The active hot water system advantages that comes with it. It have some advantages in terms of performance and access to it. Systems can be operated all year round. Active solar heating systems are most cost efficient in cold climates with cold solar resources when they are displacing the more expensive heating fuels such as electricity, propane, and oil. Disadvantages that comes with it. It is very expensive and have a lot of moving parts, so it may need a more maintenance. And the supply of demand when it comes to the parts isn't readily available. The passive water system. These systems use the basic principles of the greenhouse effect to produce heat. The whole idea is to trap some fluid, air, or water in place and leave sunlight through the walls in order to heat the inside The technology might seem too simple, but it is productive enough. In fact, some systems provide efficiency up to 70%. That means that they harvest 70% of solar energy radiated at an area and transform it to hot water. On the left side, there is a picture of a passive solar water heating system. The passive hot water system comes with advantages such as it has fewer working parts. This may make it easier to maintain, and it is less expensive than active solar water heaters. Disadvantages that comes with it takes up a lot of space, and it is very heavy for something to be stored on a roof, and depending on the structural integrity of the roof, you might not want to put something as heavy as this on your roof. And no water, and there won't be any water for a few days if there's been cloudy days. Here is a video to demonstrate the active and passive hot water systems.
In this video, you'll learn how to identify the most practical setup for a solar hot water system based on the needs of the climate, building and the householders.
In passive systems, also known as thermosiphon systems, the tank sits above the collectors. Colder water sinks into the collectors, whilst warmer water rises unassisted from the collectors into the tank. The tank may sit on the roof with the collector, a close coupled system, or within the roof cavity above the collector, a gravity feed system. With these systems, the roof support structures must be strong enough to handle weights of up to 800 kilograms. Active systems use a small pump to move water between the collectors and the tank. The location of the tank can be within the roof or on the ground. Each type of system has advantages. A passive system is space-saving and is easy to maintain with no moving parts. An active system is unobtrusive, lightweight, can use an existing tank, and the tank can be located closer to where hot water is used, reducing heating loss in pipes, but the pump uses some energy. There are two collector types to choose from: flat plate and evacuated tubes. Evacuated tubes have the advantage of receiving perpendicular radiation for a greater part of the day. This, combined with their vacuum insulation, means good winter performance. Flat plate collectors, particularly if purchased as part of a closed couple system, can be more affordable than evacuated tube collectors. However, the prices of evacuated tubes has fallen in recent years. Collectors should ideally face true north in a shade-free position. Facing the collectors 45 degrees from the north will result in only minor reductions in performance. The ideal inclination is the angle of latitude plus 5 to 10 degrees. Sydney's latitude is 33.5 degrees, so an ideal angle of inclination would be around 40. However, plus or minus 15 degrees would still provide adequate performance. If your collectors face due east or west, the lower the angle of inclination, the better. However, to allow thermosiphon flow, you must always keep the angle above 10 degrees. For the correct sizing of your collectors and tank, consult manufacturer's guidelines to see what is best for the climate and household. In places with minor frosts, evacuated tubes may offer enough inbuilt protection. In climates with regular frosts, indirect or closed-loop systems are the most popular and reliable form of frost protection. Instead of water, an antifreeze fluid is heated in the collectors. The antifreeze passes heat onto the water via a heat exchanger. The antifreeze does not come into contact with the household water supply. Other frost protection methods are available, such as frost protection valves, temperature programmable pumps, and drainback systems. In an Australian summer, water in collectors can easily approach boiling point. This can cause excessive pressure buildup and can damage the lining of vitreous enamel. The Australian standards state that solar hot water systems must provide over-temperature protection without draining water, so a temperature pressure relief valve is not enough. The most common way to prevent overheating in the tank is by automatically stopping the circulation between collector and tank when the tank water gets too hot. This can be done using a solar control valve or a temperature-controlled pump. See the fact sheet on the Trade Secrets website for more information about how to control for frost and overheating. The solar hot water system will require boosting at some times of the year. Electric boosters use a lot of power, so make sure the booster is controlled by a manual in-house switch. This switch should include a light to indicate when on. Boosters which have no in-house switch or are permanently on are wasteful, as they often heat water to 60 degrees, water which would otherwise be heated by the sun. When advising the householder on their energy tariff options, explain the pros and cons of each option. A regular tariff allows boosting at any time, but it won't lead to a reduction in their bills if their previous system was electric off-peak. Off-peak will be cheaper, but may not fit the hot water usage patterns of all households. If available, extended off-peak or off-peak 2 is often a good compromise. Natural gas boosters have the advantage of lower emissions and running costs compared to electric boosters, and also aren't subject to time of use restrictions. Install a timer on gas storage boosters to ensure the gas does not heat water which would otherwise be heated by the sun. So, select the system for the climate and use appropriate temperature controls. Locate the collector and tank to maximise performance. Install a manual boost switch and connect to a tariff which minimise emissions and costs.
For more information and to download a fact sheet, go to tradesecrets.org.au.
This concludes my presentation on active and passive hot water system in a residential area. Thanks for watching.